To get started with DynamoDB, first log into your AWS account. Afterwards, you can find DynamoDB under Services and Database, and you can always search for it using this search box. So I'm going to click on DynamoDB, and I will be shown a DynamoDB landing page because I don't yet have any DynamoDB tables on this account. And what we are going to see over here is basically that DynamoDB is a fast and flexible NoSQL database service for all applications that need consistent single-digit millisecond latency at any scale. What that means is that you can start small without having to create a detailed schema because it is a NoSQL database, and once you reach a millions of users in your startup, you will still maintain the single-digit millisecond latency at any scale. With that being said, let me go ahead and click on Create Table. Next, we need to provide the name for this table, so I will be creating a database for all my Egghead lessons, so I'm going to call it my Egghead lessons. Next, we need to define a primary key. So a primary key is made up of one of two attributes that uniquely identify items, partition the data, and sort the data within each partition. What that means is that we have to be able to uniquely identify each lesson with this key. Each Egghead lesson has a unique title, so I'm going to specify my primary key as a lesson title. Afterwards, there's many table settings that we can define, but I'm going to leave everything as default. What that means is that I will be using no secondary indexes in this table. The provisioned capacity will be set to 5 reads and writes, which is more than enough for the sample example. We will have some basic alarms for this table, and we're going to also use the default encryption type for this database. Next, click on Create to create our first DynamoDB table. Right now we can see that our table is being created. This is going to take a couple of seconds, but afterwards we're going to see our freshly created DynamoDB table. Okay, now our table has been created. So we can see in the table details section that the table name was specified as my Egghead lessons, the primary partition key was set to lesson title, which is a string. We don't have a sort key right now, and we also provisioned 5 read and write capacity units for this database. If we go ahead and switch to the items section, we will notice that we don't have any items right now because by default, every DynamoDB table starts completely fresh, there's nothing in it. I have a DynamoDB table with the name of my Egghead lessons and the partition key of a lesson title, which is a string. I would like to add some items to this table because currently it's completely empty. Let me click over here to close this section on the left, and to create a new item in this table, click on Create Item. And in this view, we are able to create a new item. The only thing that we absolutely have to provide for every item in this table is the lesson title, because as we established before, the lesson title is a primary key for this table. What that means is that every item has to have a lesson title, and also this title has to be unique for every single item in this table. If I try to create a new item without providing the lesson title, I would get an error, because every single item in a DynamoDB table has to have a primary key provided, and it cannot be an empty string. So in order to create an item, I'm going to provide a lesson title, add a new item to a DynamoDB table. Let me fix the typo. And now I can click on Save in order to create a new item in this DynamoDB table. Let's create another item. So click on Create Item, and I'm going to call it Delete a DynamoDB table. And that is a lesson that I'm going to record in the future. And I would like to have a field in order to indicate whether a lesson has been published or not. Luckily, DynamoDB is a NoSQL database. What that means is that I don't have to have a predefined detailed schema, and I can instead go ahead and add a new field to this item. So I'm going to append a new field, and we can see over here that there's a number of different field types provided by DynamoDB. So we have string, binary, numbers, and also we have things like sets. So there's a string set, number set, and binary set, which are basically arrays of a given type. There's also a map, which is equivalent to a JavaScript object, more or less, because it is a key value pair. There's also a list, which is an array of various DynamoDB types. So you have an array of binary, strings, and numbers. We can have a type of Boolean, which is true or false. And there's also a null. I'm going to click on Boolean, and I'm going to call this field is published, and I'm going to set it to false. And I can go ahead and save this item. And right now I have two items in this DynamoDB table. Note that the first item, add a new item to a DynamoDB table, does not have an isPublished value. And that is perfectly okay in DynamoDB, because DynamoDB is a NoSQL database. What that means is that there's no schema and everything is a bit more flexible. So it is possible to have items that either do have or don't have certain fields in them. Nevertheless, I am about to publish this lesson. So let me click on this item, add a new field, again, append a Boolean is published, set it to true, click on Save, and we can see that this first item has a isPublished value set to true. We have a DynamoDB table with my egghead lessons, and I would like to add another item to it. So I can go ahead and click on create item. And in this tree editor UI, I can provide the lesson title, which is the primary key of this table. And I can also append fields to this item, which is fine for items that don't have a lot of fields. But if I do have a lot of fields in my items, I probably don't want to use this UI. Instead, I can go ahead and switch to a text view, and here I can provide a new item for this table as a JSON. So I can paste in a JSON that I have prepared before in order to create a new item. So this item is going to have a lesson title of add a new item to a DynamoDB table using JSON. It's going to have a set published field set to false, and the topic of this lesson is going to be DynamoDB. Now I can click over here in order to go back to the tree view, and I'm going to see all my fields that I have created as a JSON file, and each one of those is going to be either a string or boolean and so on. One thing to notice is that DynamoDB does not store our items internally as a JSON file. Instead, it's using something which is called a DynamoDB JSON. In order to see that, we can click on this checkbox over here. In DynamoDB JSON, every field is an object. So for instance, lesson title is an object with a key of S, which stands for string, because it is a string. And for instance, is published is also an object with a key of bool, which stands for boolean, because it's a boolean value which can be either true or false. With that being said, let me go ahead and click on save in order to create this item. And we're going to see that our item has been successfully created. In DynamoDB, there are multiple ways of retrieving items from a database. So in this example, I have a table which is called my egghead lessons, and it contains a couple of egghead lessons that I would like to record in near future. The simplest operation to understand when it comes to receiving data from our table is scan. So scan operates on the entire table and is going to return you all the items within this table up to 1 megabyte. So it is okay for small tables like this one, so I can scan the entire table and get those items because there's only 6 of those. If I had millions of items in a DynamoDB table, then scans can get very expensive because essentially you're going to use your read capacity for a single operation. One of the common mistakes when it comes to understanding the scan operation in DynamoDB is assuming that adding a filter limits the amount of items that will be read when performing a scan operation. My assumption, for instance, would be that if I set is published, it's going to be a boolean value of true. So in essence, I would like to get only this item. If I search it, that is correct. I am going to get only this one item. But the way that filter operation works in this case is that scan is going to go again for the entire table, but it's going to only filter the results by this one. So I may think that I'm only reading a single item from the database, but in fact, I'm reading the entire database, and I'm getting this only one item returned. So to sum up, a scan operation can sometimes be useful. Sometimes we have a very small tables and it is okay to go for the entire table. Sometimes we absolutely have to go for the entire table, even if it's large for some reason. So it's always a good idea to think twice before using a scan operation, because otherwise you may use your entire read capacity of the table in one go. Scan operation wouldn't be terribly useful if you could only perform it via the console. Luckily, we can use code, for instance a lambda function, to scan our table. In order to do that, we're going to go to services and lambda, and we're going to create a brand new lambda function in order to scan our table. So I'm going to call it scan a DynamoDB table, and we are going to use Node.js 12. And before we move on, we have to ensure that our function has the required permissions. By default, a lambda function gets a basic lambda permissions, which do not give it access to read data from a DynamoDB table. We're going to create a new custom role in order for us to be able to read the data from a table. To do that, go to Identity and Access Management console. And we're going to create a brand new role that we are also going to use in the future lessons. So I have to create a role for the lambda function, so I'm going to click over here. Next, click on permissions. And there are two types of permissions that I need to attach to this role. So first up, I need to attach basic lambda permissions. So I'm going to search for lambda, and it's going to be over here, AWS lambda basic execution role. Afterwards, I need to also attach DynamoDB read-only access, because I would like this function to be able to only read the data from a DynamoDB table. Remember, AWS follows the principle of least privilege. So the idea is that the resources have only the access to the things that they actually need. So as an example, in this case, we are not going to give this function DynamoDB full access permissions, which are over here, because I don't want this function to be able to, for instance, delete a DynamoDB table or write data to it. I just want it to be able to read something. So next up, I'm going to click on tags. For the time being, I'm not going to add any, so click on review, and we can see those two policies that we just attached. So AWS Lambda basic execution role and Amazon DynamoDB read only access. So I'm going to call this role DynamoDB read only Lambda, and it's going to allow Lambda function to read data from DynamoDB table. So now we're able to go ahead and create the role. And now we can see that our role has been successfully created, so let's go back to the Lambda function. So over here, instead of creating a new role with basic Lambda permissions, instead I'm going to use an existing role that we've just created. So I'm going to search for DynamoDB read-only Lambda role, and next up click on create function. And now our function has been successfully created. So let's scroll down a bit in order to implement it. In order to interact with DynamoDB from Node.js, we're going to use a DynamoDB document client, which is a high-level API that allows us to interact with DynamoDB API without going in too deeply into different quirks of DynamoDB. So it's excellent for create, read, update, and delete operations. So first up, we're going to import the AWS SDK. So const AWS require AWS SDK. And afterwards, I'm going to create a new document client. So const dynamo equals new AWS DynamoDB document client, like this. And next we're going to create a new function, which is going to be called get all lessons. It is going to be an async function, and it's going to scan the entire table. So const scan result equals await dynamo scan, and scan takes an object as an argument. Basically, we need to provide only the table name. So I'm going to provide a table name, which is called my egghead lessons. Actually, a better approach would be not to hardcode this table name inside of this Lambda function, and instead scrolling down a bit and using the environment variables to do that. So I'm going to quickly create a new environment variable, which I'm going to call table name, and I'm going to pass in the value of my egghead lessons. Let me save that. And now instead of using this hardcoded value, I'm going to do process env table name. Using await requires a promise, so we have to call that promise at the end of this scan call. And afterwards, I'm going to return the scan result. Let me go ahead and call this function over here. So I'm going to do const data equals await get all lessons. And I'm going to return this data as a response from the lambda function. So instead of this hard-coded hello from lambda string, I'm going to simply JSON stringify data. Let me go ahead and save this function, and let's test if it works. So click on test in order to create a test event. Right now we don't really care about what's inside of this test event because we are not using any of it. So I'm just going to clear this out, and I'm going to call it my test event. Scroll down and click on create. One thing, there's a typo in this code. Both D and B in DynamoDB are uppercase, so let me go ahead and fix that. Click on save, and let's test this function. So click on test, and we can see the response over here. So the response contains in the body all the items that we have in our database. To recap, in order to use a lambda function in order to get data from DynamoDB table, first up we need to attach a proper execution role to this function so that it has access to DynamoDB table resources in the first place. And next we can use the DynamoDB document client API, which allows us to call different functions on a DynamoDB table, such as scan that we see in this lesson, in order to get data from a DynamoDB table.